Hey guys, today we'll be doing Unit 4.1, but we're going to finish this part. I'll do it in green. Okay, so fats and oils from fatty acids and glycerol, and I'll try doing more. Okay, so lipids or fats and oils. I'll circle the whole thing. Now, this is going to be over here. So large molecules are made from smaller molecules. Now lipids. Okay, so it's made of the lipids and proteins. So fats and oils or lipids and proteins are made of I'm going to do a different color. 1 unit of glycerol or glycerol and 3 chains of fatty acids attached to it. Now, a diagram to help remember how a fatty acid looks like. How fats and oils look like is this. So I'll make glycerol yellow. Okay, I'm not gonna do that much, whatever. Okay, and I'll make the fatty acids of this color. Okay, so this is glycerol. So it's 1 unit of glycerol and 3 units. So I'm not going to do that. So this, and this is fatty acids. Okay, so this curve, this chain is called a fatty acid. Okay, the whole thing is called a fat or a lipid or fats, lipids, or oils. Okay, now for proteins. I'm going to talk about proteins over here because it's the longest part. Okay, now proteins, they are made of, it's a really good idea if you write this down because it's important. Made of long chains of amino acids. There are 20 different types of amino acids that exist. Okay, now there are different sequences of amino acids result in different types of proteins with different 3D shapes. So different sequences. So let's say I'm going to write it, then I'm going to explain. Different sequences of amino acids gives different types of proteins. With different (3D) shapes. Okay, so let's say amino acids, it's malonyl and leucine and valine, or in glutamine and cysteine and glycine and lysine. Let's say if it's, oh no, not this color. Let's say the amino acid, it's LGF. Okay, let's say I produce, okay, this is going to make a specific protein. Okay, if I make GLF, GLF, it's going to be a different protein. They're not going to be the same. They're different proteins. That's basically what it means. Different sequence of amino acids give different types of proteins with different 3D shapes. Okay? Now, that's done. Shape of protein. Third point. Shape of protein. It's important. Is extremely important for their function. Okay? Now, the chain of amino acids in a protein takes up okay, so explaining this, the chain of amino acids in a protein takes up a particular shape. Okay, it takes up a particular shape. Because of cross linkages. Okay, these are because of cross linkages between them. Now, shape of protein is extremely important for their function. Okay, the shape and structure of protein. Shape and structure of protein. It has an important effect on. Okay, this a colon. Okay. Important effect on two things. Okay, it's really important. It's on the syllabus too. So it's on the active site of enzymes and the binding site of antibodies. Okay, the shape and structure of protein, it has an important effect on active site. So basically, when for the active site, if let's say I'm also gonna teach it in the other chapter, but I'm just gonna give a brief description. If this is A, just think of this and this. This is the substrate, and this is the enzyme. Okay, for the substrate, each enzyme is specific. Let's use this color. Each enzyme it's specific to a substrate. It's specific to a substrate. Why? Because this part is called the active site. Now, the active site, the reason why it's specific is because the active site is made in a specific shape that only, only the enzyme can fit in it perfectly. Okay, so if shape and structure of protein, it's different. If the shape and the structure of protein is different, it's because obviously it's because of a different sequence of amino acids. But if the shape and structure of protein is different, the active site is different. So shape and structure of protein it has an important effect on active site and binding site of antibodies. You have to know that well. Okay, okay, that's all for